Welcome everyone. My name is Lukasz Woznicki. I am a software engineer working with Finnish, and we've been building this framework for a while now. So we wanted to show you how we can easily extend some of the functionality. Presentations. Probably not click. Right, so the first thing I would like to actually start today with is a short presentation. So very similarly to the previous presentation, I have had set up my device previously with Finnish already running. Right, you can see this type of a device, Finnish IO, and go straight to the point. So for the software management, we often use different package managers, and it sometimes may be very daunting how we would manage those software. And with the extensibility of Finnish, I can add different plugins. So I wanted to show you my device again. Right, so my device is already running Finnish IO on board, and I just wanted to quickly show you how easily it can be to manage software on that device. So we're going to be talking about Snap today. I have already put some snaps inside my device, and if I just install and then apply changes, that's going to send a couple of commands to my device. You can see the status here. We should see in a couple of seconds. Now it succeeded. And I just quickly refresh my list. I know I probably went quite quickly, but now we can see another package installed on the device. So this is what we're going to do today. Pretty much how simple it's going to be to install or remove software on your device. I'll just quickly now remove that from my device. And okay. Let me go back to the PowerPoint. Cool. Right, so before I jump into the coding, I would like to give you a quick refresher regarding the architecture and how is it possible that building such components with Finnish is so straightforward. So if you look here, you can identify the standard here, our bus and some of the data mappers which are responsible for exchanging the messages with the cloud, and further down the line, actually the component which we are going to be focusing on today. Oh, sorry. Oops. And everything's broken. It worked much better yesterday. So the component which we are going to be focusing on today, which is device management agent, as well as the plugins. So just to quickly summarize, the part we are going to work on today is that software management plugin, which is a dependency for an agent to support new package managers. New package managers. We can just add a new plugin. Out of the box, Finnish comes with an APT plugin for Debian distributions, as it is one of the basic methods we distributed, but we also offer you some basic implementation for the Docker plugin. So if you would like to try it, feel free to do so. But what's so great about the software management plugins is that even though the agent and the core of the Finnish is written in Rust, those components or those plugins can be written in pretty much any language. So today we will be doing this with Python. But before we jump into that coding, I'll do a little bit more about the contract between the plugin, the agent, and the cloud. So if you imagine here on this side, we have our cloud mapper, which is connected to our cloud, wherever you want it's going to be. In my case, it's Cumulosity. And on the device, simultaneously going to have running an SM agent. So the agent is a main process running around executing operations on Finnish. And therefore, any requests coming from the cloud after translation by the cloud mapper, they will be pushed out to the agent. and depending on the type of the operation requested, so in our case, it's going to be some kind of software update or software list request, the agent will invoke the appropriate plugin. That's either going to be for APT or as we're going to do today, it's going to be Snap. So what happens between the agent and the plugin? They do exchange small information package via the plugin API. That's a command line interface that is happening due to the agent actually calling the software management plugin as a child process in the agent itself. So they can easily exchange exit codes and other parts of the messaging system. So to give you a little bit more details about more complex operations, I'll probably zoom in, it will be easier to read that. We're still having the same components, the software management agent plugin, and on the right-hand side, mapper, which is going to be a little bit less relevant at this point as, whoops, again. So what happens when software management agent receives an operation? It will store some state internally to just be sure that we are, after any crashes, reboots, or power losses, we still can continue execution of the operation. But the agent will call a few commands which are defined by the plugin API, and the plugin should respond directly to the agent with predefined responses. So by those responses, what I mean, the main way of communicating is the exit codes of the processes, as well as in some cases standard outputs and standard errors. So it's mainly for the list command. So the process, sorry, not the process, but whenever agent invokes the plugin, it's going to invoke it with a certain order of operations. So always when you have a software update request, so either install or remove an application, there will be a command called prepare, which I'll show you what we can do with that. But it's going to be either update cache or update some configurations, depending on whatever your plugin supports. After that, the agent from the right-hand side is going to call the install operation. So default way of invoking that is by by providing so-called update lists. This list it should be provided on the standard input for the plugin. But in our case of Snap, because Snap, as far as I know, does not support multiple types of operations in a single call. For example, you can't install and remove in the same. So in like APT case, you can call apt install, but you can put the, I believe it was the dash to actually remove the software in the same command. So in our case, the agent will call the plugin with the requested packages one by one, and if that would be a remove command, it would also call it like that. And at the last part of the request, still on the from the agent, the plugin would be asked to finalize. So in case we would have some cleanup to do after the installs, we can also add these additional operations to be executed by the plugin as the last step of the installation. And as the last part, because we need to also update the state in the cloud, we will request the list from our plugin. Okay, I hope I didn't go too fast over that. I have links, so all of that is documented and it's in our documentation repository. So I will share the links obviously with everyone. They're going to be available in the code example as well as on this presentation, I believe. Right, to just quickly summarize. just to summarize, so what we're going to do today is the quick implementation of a plugin in Python. We are going to implement the 3 basic commands for the plugin, which is install, remove, list. Unfortunately for today, we won't focus on the update list. I think there would be a way to work around that. We could do it, but it would be a little bit longer session how to do it properly. Okay. So I'll now script to code this, and that. So I have prepared just a skeleton of an application in Python. I use Click as my command line interpreter. Feel free to use whatever you actually need or are more used to it, and you can do exactly the same things with argparse. I have made a couple of assumptions already that, first of all, we obviously have our snap already on the device properly installed and configured. So if I'm going to call on my device here, snap version, for example, the snap is, as you can see, installed and configured and running. And the second, I think, quite obvious part as well, my finish deployment is on the device as well. So all the services for finish are running and are very happy to exchange messages with me. Right. I'll come back to the status codes in a second. And I think the best or the easiest command to implement will be the list command. So this is the most basic command supported by SM plugin, software management plugin, and this will be called actually quite often. As far as when it's called, it's pretty much on every single mapper restart currently. So we will ask for the current status of the list of the software on our device, such that the agent will gather all the available plugins and will then forward the list to Cumulosity to your cloud. So as you can see on here, I also have an APT plugin on my device installed. So the other applications are those installed by APT. Okay. Right. All the specifications very similar to how-to guides are available in our GitHub repository. I'll have links over here, and very similarly to actually what I'm doing today is also available as a how-to guide. Again, links available here. The code I'm writing today will also be available in Finish examples repository, so you can always go there if you have any proposed changes or you'd like to extend it. Please feel free to go there and take it and play around it. Right. So with snap, to list the available software on the device, there is the command called snap list. So as you currently can see, I've got a couple of snaps installed, and what it does, as you can see here, it returns on standard output, it returns the list of software currently installed with some headers and stuff like that. But what the agent is actually expecting is a tab-separated list of values, and the agent only needs the name and the version of currently installed snap. So let's start with some basics. So first thing I want to do here is to invoke the process. Sorry, just give me a second. So I want to invoke my process. So in Python, one of probably many ways of doing this. And in this process invocation, I want to call my snap with the parameter or argument list, as we just saw on the command line. There are a couple of things I need to modify to make it look a little bit better, and also to have additional reporting. Also, in case we have a failure of the software, there are logs on the device created by the agent via capturing the standard outputs and standard error. So that is really useful when you want to debug remotely. So to do that in Python, and there may be some better ways, but we just pipe our standard output, and the same we're going to do for our error. And one other thing I found actually very recently, so we changed Python, and it's quite useful to add these universal new lines characters here. Right, so what we have here now is the invocation of our snap with the subcommand list. I'm going to store that in our proc. Obviously, very important information we now need to know is if that succeeded. Return code. So if it didn't succeed, here we have to change a little bit our exit code. So the way the agent and plugins relate to each other is that the default basic information for the agent about the invocation of the plugin is the exit code of the child process. So we have 4 basic codes defined currently. So obviously error code or exit code 0 is the success. There is the failure on number 2, and you can also going to use number 1 today in one of the commands. I'll get to that in a couple of minutes, few minutes. So in the case if our invocation failed, we want to return exit code 2. So this is what we're doing in this line here. Now we have to do a little bit of string manipulation because we need to convert this format into this much simpler tab separated value. So again, there may be better ways, but I'll just quickly try to split lines there, and these are all delimited by a space or white space character, and line terminator. We have to indicate that it's /n, because for some weird reason someone chosen that the dict reader actually defaults to /r/n. Yeah. So now having that, the only thing left to do, as I already mentioned, all the output should be the whole list should be printed to the standard output, which will be captured by the agent snaps, and therefore we can do just simply, happily enough, using Python 3, so that's a fairly simple operation. And we have a name as our header name, yeah, and then we want to separate it by tab, and here version. Okay, and this is pretty much what we need. So if I now test my snap plugin, if I just call snap and list, oh, I forgot about this. Quite easy way, or the way I most of the time debug these when writing a plugin is just invoke them in a command line, because bear in mind that it's going to be pretty much exactly the same way as the agent would invoke them. So our snap list currently has sorry, there's a little bit of confusion I may be introducing now. So here on this right hand side you can see that I have invoked snap without the /. This is because this is a system command responsible for the snap CLI, whereas this / is invoking my current plugin on my device. So this is exactly this executable I'm invoking. Okay, cool. So this seems to be working. It creates exactly the expected output here. Right, so this is tested. Next part of our plugin to be implemented will be, I suppose, the two most interesting, maybe not interesting, but important commands for our software management. So how to install and remove a command. The code in here requires a little bit more parameters. So the first parameter captured by the plugin needs to be a name of the software we want to install. And second is the version, and then third is the file. So some package managers, unfortunately, Snap does not support the explicit version installation. With Snap, there are ways to work around that. We can make it to work in a developer mode, but then after a first auto update, it would revert back, or actually sync up with the latest stable anyway, or latest on the current channel anyway. So I decided that for this demo, it just makes it's not practical to implement the particular version installation. And the file, in the case if you need to install from local drive, or if you need to download your package from some other source than a publicly available stores or repositories. So in case of Snap, it would be Snap Store. You can download this from external source, and the agent will manage the downloading that and then ask the plugin to install it. But again, for Snap, without enabling the developer access to the snaps, it's not possible as far as I'm aware. Actually, there is not much new code we need to write, because bear in mind that plugin is just as thin as possible layer to talk to our package manager. The layer is basically the plugin API, and internally the plugin, whichever language you want to write it, Shell, Python, Rust, it has to call appropriate package manager commands. So small change we need to do obviously here. One is to say that we want to install, and the other thing we want to do is to say which package we would like to install. So yeah, in our case, for Snap, the command is install, and then it requires a name of the package to be installed. That's taken from our std, our command line parameters. Okay. Funnily enough, that is pretty much all we need to do, because we're piping the std out and error from the sub process. We don't actually need to return much here, and only in the case of error we want to return exit code 2. We have very similar situation with remove. So the difference between install and remove is that remove obviously does not require a local file. So we're only going to provide a name and a version if the package manager would support that. Right. So for our Snap, we require to change the command to be remove. And one additional thing which I think is a good practice for especially edge devices is to add this small switch over here, which is going to force removal of all the snapshots, metadata, or like remainings after the removal of that package. Cool. So now we have list, install, and remove. So pretty much the basic API currently implemented. There are three more methods, three more functions which I have prepared here, which I already mentioned before. That there is the prepare and our finalize. So in finalize, we are not going to do anything. So we just simply pass here, but we still need to implement this for our plugin, because if we're not going to return exit code 0, that would tell the agent that something wrong happened. It could fail the whole operation. And for the prepare, we can actually do one thing here for Snap, very actually similar to our in general the APT or other things which rely on shops or external spelling is difficult, external repositories. So every time we receive an update operation or for the plugin, we would like our repositories to be actually nice and fresh, and then do exactly, excuse me, always install the latest version. So in snap, there's a command refresh. As I already mentioned, there is also our special case, the update list. Currently, I don't believe the snap supports it, or not in a straightforward way. We could probably do some, accept the whole list and do processing and splitting between install and remove. But yes, I decided we're just going to leave it to the agent, just show you how simply it may be. But to actually make it fully working and to let know the agent that actually we do not support this operation, there is this special exit code 1, which we can return from the plugin for the update list. And yes, that is pretty much our whole implementation we need to have this simple plugin up and running. The last thing left here is to actually install that plugin. So if you just give me a second, I'll just quickly relog here and test that plugin. So what to do to install your plugin? That's also actually, I suppose, a good question. So I'll demonstrate that on my dev machine. So all the plugins need to be put in an etc teg sm plugins directory. This is a special directory in the teg configuration directory where we keep all the plugins, other operation configurations and stuff. But here, as you can see, I already have copied before a file, but if I would be doing this right now, I would do my snap.py with sudo to my etc teg, oops, not plugins, obviously, but sm plugins. And the important part here is the name. So as you can see here, I'm dropping the .py extension because if I would leave the extension, the plugin would be registered as snap.py, and therefore I could have weird type of like snap.py. So therefore, whatever the name of the plugin in teg, that's what we will see up in our cloud. Okay. I think that is pretty much all I have to show you guys. Just to get this one up and running. Oh, I know what I forgot to show you. So what actually is going on the device. So I'll quickly just do these. I hope they're still visible. I need to switch back to my device, and here I'll go with Mosquito. So as already mentioned, teg is using the bus. The bus is basically a MQTT connection. So that allows us to actually see the messages we want to see on the device. So as you can see, there was just some exchange of messages happened. So whenever I remove and will ask my plugin to get removed, there is a bunch of messages. As you can see, there is actually quite a lot of stuff happening in the background. But because this is all handled by the agent as well as the mapper, we don't have to worry about it on our plugin level. So as you saw before, I did not touch MQTT at all, and here we can see our request to remove our plugin. Sorry, not plugin, but the application. Right, so the application is not here anymore. Just to reiterate, all I have done here today is described in that tutorial. Oh, wrong buttons again. and this is how it looks like. So in this under this URL, you will find that tutorial written by someone from the team. This is using the shell and shows you how to implement Docker, but you can either do exactly the thing I just did, so just do it in Python, or you can implement it in any of languages you prefer. Just to also quickly show you the other stuff I was talking about, the plugin manager plugin API. So that's also nicely described here in documentation of the repo. If you want to look at more of the flow between agent plugins or other components, there are also other subsections where you can go and check. Right. I think this is all I have to show you guys today. Thank you so much. I hope this was useful. And yes, this will be published very soon in the Finnish examples repository. Thank you so much, Phil. Back over to you.
Great, excellent. Thank you, Lukasz. So let me just warm up this material once again. Brilliant demonstration. Obviously, we're keen to do live coding, keen to get in there with the positive negatives of the demo effector sectors. But Lukasz, brilliant. Thank you very much. So one of the questions I kind of noted as we went through was so you were talking about exit codes for certain kind of sys.exit events, and I think you then went through on the API description what those exit codes were. So kind of 0 being something, 1 being something. Do you want to just briefly highlight that once again?
Yes, of course. Just give me a second to bring up the other web pages. Okay, cool. And share again. This screen share that. Right, so I'll do this time. I'll use the documentation. So those exit codes are also highlighted in the tutorial how to write your own plugin. So yeah, the most basic and you know the one you always want to see is the 0 exit code that highlights the agent that the operation had been successful and does not require any further operations. The exit code 1, as you saw in the example, because this plugin does not support, for example, the update list command. This can return that exit code and also highlight to the agent that it has to use the other methods, non-default methods to install the application. So one by one. The code 2 means that something in the execution. So when we try to call the snap, in our case, some command failed, either due to a permission issue or some other. And altogether with that exit code 2, the plugin will return an event which will show you where the logs are for the device. If I have enough time, a couple of minutes, I may show you an example log of such failed operations. If that would be of interest to anyone.
I think if it's short and sweet, I'm sure the audience would be keen.
Okay, no worries. This one, okay. That's my mess here. Okay. So let's quickly cut that's in var log attach agent software. Okay, I've got some other logs, so let's do 20. Whoops. Software update. Oh yeah, sorry. Update 22T, yeah, 1527. Okay, so if I cut that file, as you can see, it contains pretty much all the std out and std of the operation. So there was some other issues I had. Oh, there was some list even. Sorry, this is the last invocation of the list command. So it shows that the exit status was 0. But in the case of error, do I have anything here? Don't think actually this is, yeah, That's actually some successful operation. But yeah, in case of error, that file path would be passed an event, and you can access it via agent again and push out to your device via other operations.
Excellent, excellent.
Someone said my screen is gone, I believe.
Yeah, I can see it here. So hopefully it's just a temporary glitch in the connection somewhere.
All right.
So brilliant, Lucas. I think it's probably useful now just to. I think we've got a couple of questions coming through. So one additional one for Lucas yourself. So there's a number of package management or packages that are already handled in Synerge.io. So which ones are already available? Could you just say what those are?
Of course. Yes, so out of the box, Synerge.io provides the APT plugin, which supports the APT and APT get. So if you require, or if you're using Ubuntu or things based on Debian packages, so supporting Debian packages, there is one available, and the other officially supported is the Docker plugin, which I think is based on the tutorial example, but with a little bit more extended functionality.